So limiting reagent problems, more real life type of thing, because in real life you have to predict product amounts and reactions with multiple reactants, where one reactant gets used up first. That's how it always is. I mean, they never add the perfect amount of each reactant, right? So you don't waste anything. You just add them, and some reactant is going to get wasted because one of them is going to get reacted up first. Everything stops. The producing product stops. The reaction stops because that one reactant is completely gone. That means you're going to have other reactants and they're left unconsumed, leftover, excess, waste. So you try to minimize that, but so that's a good reason for knowing how to do these types of reactions, because maybe one reactant, which is usually how it is really expensive. So you want that one to be the one that reacts up first, right? So it's useful stuff here. So let's take a look at this. And let's start with s'mores. Now, Melissa, have you made a s'more before? No? Okay, well this will be a good experience for you then. So this is my recipe for making s'mores. So I'm going to have 2 graham crackers, one on top, one on bottom, a lot of marshmallows, 9 of them. It has to be those little ones, right? And a complete chocolate bar. Wrap it up, put it on top. And then I'll break it in half, and I'll have 2 s'mores that way. So it's a camping thing. Okay. So all I brought camping, though, was 18 grams, 90 marshmallows, and 7 chocolate bars. So just by looking at my reaction and what I brought, can you, by eyeball, figure out how many s'mores that can be made? I hear a 7. Well, a 7, you're looking at the chocolate bars, right, Oscar? But remember, for one chocolate bar, you get 2 s'mores. So really, that'd be 14, right? So 14 is a possible answer if you use the chocolate bars. The marshmallows or the grams. I hear a 20 and a... But 14 is a small number. Should we just go with 14, be done with it? Because eyeball's not so easy, right? So we need to show the calculations. Let's actually work this out. Let's do the chocolate bar one first. So just like we have before in the past, we start with the amounts of reactants. 7 chocolate bars. And we do a conversion. We want to convert to s'mores. So I'm ready for my mole bridge, right? I have 7 chocolate bars. This very first step, Erica, what ratio am I going to put right in here? My mole bridge for my reaction. What would you put? 1 chocolate bar. It has to be on the bottom because it has to cancel. 1 chocolate bar for every 2 s'mores, because we're after s'mores. She could have picked something else, but we're after s'mores. So 7 times 2, 14. Right? So now do the same thing for the 18 graham crackers and the 90 marshmallows. See what you get. Do the same thing for the 18 marshmallows. Sorry, the 18 graham crackers and the 9 marshmallows. 90 marshmallows. Trina, did you figure, what did you get for the s'mores for the 18 grams? Two s'mores at the top. Oh, it should be 2 grams, right, at the bottom. The mole bridge would be 2 s'mores for every 2 grams. See where I got that? No? That's okay. It's a reaction. It's a reaction. It doesn't matter what it is. The ratio is 2 s'mores to 2 graham crackers. So in this reaction, that's where I get all my ratios. Right? Do you see where I got it? Okay. So you'd end up with just 18, right? And then with the marshmallows, hopefully everyone, you guys get 20? 20 s'mores? Okay. So looks like there's 3 possible answers. We picked 14. Right? Does that make sense? Is the answer 14, or is it 18, or is it 20? It's 14. Why? It's the least amount you can make, yeah. But it doesn't really explain why. Pick the 21, sorry, pick the 18. You only have enough chocolate bars to make how many s'mores? 14. There's no way you can make 18. There's no way you can make 20. You only have enough chocolate bars to make 14. Okay. Some terminology. What then is the limiting reagent? What chemical, well, loose word, what chemical limits everything? The chocolate bars. The limiting reagent is the chocolate bars. Okay. So theoretically, how many extra marshmallows are there? Christian, we're going to need a game plan for this. Right? Since the chocolate bar is the limiting reagent, it's going to get all used up. That means there's extra graham crackers and extra marshmallows. How could you figure out how many marshmallows are left?
6 times what we use, 6 times 9.
Oh, okay, I see what he's coming from. I think I see what he's coming from.
If you have 20, if you have enough for 20, then you subtract however many you actually made, multiplied by however percent left.
I think that might work. It's hard for me to visualize it. I guess my brain's only stuck in one mode.
Oh, do you want the
how many are left over? I guess what I'm going after is
doing that?
doing this kind of thing. But it might work what you're saying. But where I'm coming from is use the limiting reagent to calculate everything. Because you know that the limiting reagent is the one that's used up. So if you use anything else, any other amount, could be s'mores, whatever, you're gambling. So use a limiting reagent for all calculations, because you know he's going to get totally used up. That means whatever you produce or whatever you calculate, totally used up. So if I convert 7 chocolate bars to marshmallows, that would be the marshmallows that are used. There you go. Is that what you said? Okay, that's what you said. So you're right then. So let's do this. Figure out how many marshmallows are used, and then subtract it from whatever we had at the beginning, right? Let's see, what's the ratio of chocolate bars? There's always one chocolate bar. But I liked a lot of marshmallows. What was it? It was 9. So So 9 times 7 is 63, right? And then Clarissa, right? Clarissa said subtract out the 63 from what you had there originally. How many did I have originally? Had 90. Is marshmallows left. 90 minus 63 is not, it's 20.
27.
Thank you. Oh, God, I need the calculator so bad. Isn't that sad? Okay, 27 marshmallows left. But the point is use a limiting reagent for all calculations, right? We can use a limiting reagent to figure out any product, right? How many, I don't know, graham crackers did you use? Use a limiting reagent to figure it out, okay? What is another term? What is the theoretical yield of s'mores produced? Jonathan, what do you think that number would be? What is in theory, how many s'mores can you get is what it's saying. Well, we said 14. 14. We said in theory 14, you should be able to make 14. So that's what theoretical yield is. So theoretical yield is the amount of product in theory you should get if all the limiting reagent reacts up. Okay. Now when you make a s'more, it's dark, there's a campfire usually. People aren't really focused on making s'mores, they're more just eating the stuff. So you're lucky if you got 7. So this guy, actually we made 7. So 7 s'mores were actually made. What is the percent yield? Well, here's our equation for it. So what would you do? 7 all over 14 times 100. Be 50%. That would be our that's our percent yield. Actual over theoretical times 100. Okay? So with s'mores, with chemicals, it's the exact same thing, except now you just have to worry about molar mass. Okay? So it looks a lot uglier, but it's not that bad. So we're going to go to the boards and work this out, but I just want to make sure you see the game plan, right? The game plan is they give us this reactant and they give us that reactant, right? 24.2 grams of this stuff and 32.6 grams of that stuff. And they want to know what? Grams of water. So we'll convert everything to grams of water. Right? And your smallest answer will be the what yield? Theoretical, right? I think you're ready. Question? Yeah, you have. See, it's twice as much work, right? Clarissa, it's twice as much work as last class period. It's the exact same thing we did, except you have to kind of think about your answers at the end. So we're going to start with 24.2 grams of ammonia and convert. And then we'll start with the 32.6 grams of oxygen and convert. Right? Comfortable with this? Ready to try it? Yeah, let's try it at the boards. I think, because then everybody can see what everybody else is doing, and there's a lot more talking going on. And that's what you want. You want to explain it to some other people. Yep. Yeah, you bet. Okay. Everybody sees the game plan, hopefully. Bless you, Erica. So remember the first step? Molar mass. Grams NH3 and 1 mole of NH3. And then GH2O. Yep. Yeah, 1 mole. In fact, you know what I like, Carissa? You see what Alejandro's doing over there? He did all units.
First.
All units first. And then now he's putting in the numbers.
Oh.
It's kind of easier that way. Because then you don't make silly mistakes. But it really doesn't matter.
And then you do the mole bridge.
Then you do mole bridge. And we're after water. Yeah. Good. Excellent. Keep going. Yeah. Now you're ready for mole bridge. Right? See, you know what you can do, Oscar, that kind of helps things? See what Danielle's doing? You may not like this, but she just puts in all of her units, and then she fills it all in. It might be quicker, I don't know.
Yeah.
It has to be moles. Yeah. Looks good to me. 38.4. Now you got to do the other one. Let's see. Whoa. See, right, MOL here, 6 moles of water.
Oh.
Right? And then in 1 mole of water, right, 16 and 2 is 18, not 32.
Oh, I did 6. Oh, I thought. Okay, I see what I did.
Yeah, it's 2 H's and 1 O. So 16
18.
plus 18, yep. And then do the NH3. And the NH3
I
isn't
did
a
16
1,
times.
right? The NH3 in front of the NH3 is a 4. Do you see it? Yeah. There. Now you got it. Now you're ready to do the next one. And this is an 18.
Oh.
Because 16 plus 2. And this is just 14 plus 3 would be 17.
Why am I getting all these?
I don't know. Good. So if you got it, identify your limiting reagent and identify the theoretical yield. If you get it, identify your limiting reagent and identify your theoretical yield. This is good. You got it. And go on to part B if you can get it. So where's your limiting reagent? Yeah, good. And your theoretical yield is, there it is. Okay, good. Make sure you do part B before you erase everything. The actual yield is 18. Find the percent yield. What did you get, Alejandro? Do you remember what you got for percent yield? 81% or so? 81.8%. Is that what you got, Christian? You remember that number? Okay. Comfortable with that, Krista? Okay. So, Annabelle, you comfortable with this?
I'm getting there.
Okay. Okay. So I can give you a hand over there. Let me all right. So for this one, well, let you guys work on it. Let's see if you can figure it out, and then I'll give you a game plan if you can't figure it out. Okay, did you get this? 5 mole
Yeah.
oxygen
And then 6 mole
of H2O.
H2O.
Yeah. Go all the way to grams of H2O.
And then 1 mole of
H2O. It's molar mass. That's molar mass. Yeah, always a 1 down there. 1 mole of stuff, and then grams of the stuff. It was just 18. 16 plus 2 would be 18.
Oh, yeah, we said.
Yeah. So the first one you got 38. So let's see what you get for this one. Hopefully you get 22.
What'd you say?
22?
Oh, I got it.
Yeah.
Yeah.
So that's the smallest answer, so that will be your theoretical yield, limiting reagent. Okay. Now this one has a twist to it, right? So let me give you, since I've taken a lot of exams and tests, I read a question and I can see the least amount of effort to get the answer, right? Typically in these questions, you got to calculate these amounts and go to a product. But I don't want to do that because I see this second question. They don't care about a product. There is no theoretical yield. They don't care. They want to know how many grams of each reactant remain. So what I'm going to do, here's my game plan. I'm going to convert, you don't need all that space. I'm going to convert each reactant to the other reactant. In other words, what do we have? We had 30 grams of carbon disulfide. I'm going to, if all of that react, how many grams of oxygen will I need? Because one of these cases is going to happen. Either all the 30 grams of carbon disulfide is going to react, or or all of the 35 grams of oxygen is going to react. And that'll require how much carbon disulfide. You see that? So either all the 30 grams of carbon disulfide reacts, or all the 35 grams of oxygen reacts. One of these is going to happen. So one of these is going to be a complete waste of time, but I have no idea which one it is. So I got to do both. So convert, if all this carbon disulfide reacts, how much oxygen will I need also? If all the oxygen reacts, how much carbon disulfide will I need? Try it. And then see if you can see what the answer is after you do this. Very good. Good. Okay, you have enough to figure out the answer. See if you can figure it out. What did you get, Alejandro? You got a 27.7 down here. And what'd you get for the oxygen? About 37.9? Is that what you got? 37.9 and about 27.7, okay. So see if you can get this far.
Is the lowest one the one that remains unchanged?
They want to know how much of each reactant remains at the end.
So are we not answering A right now?
Well, I answer B first, then I'll answer A.
Won't one of them be 0?
Exactly. One of them at the end, one of them's going to be 0. Yeah. Yeah, you got it. That one, there's not enough. There's not enough. Yeah, you can't, all of that can't react because you need this, you need a lot of oxygen, 38 grams. You don't have 38 grams, you only have 35.
Yeah.
So this one was a big waste of time, right?
Yeah.
Okay, did you guys get this far? Which one of these calculations, the top one or the bottom one, is just crazy? It was a waste of time. The top one, because 30 grams of carbon disulfide require almost 38 grams of oxygen. Well, you don't have 38 grams of oxygen. All you have is 35. So that top one is garbage. It was a waste of time. It can't happen. So, okay, fine. Well, we didn't know, right? The next one, 35 grams of oxygen react. That requires 27.7 grams of carbon disulfide. But how much carbon disulfide do you have? 30. Aha! So this will happen. This is the one that theoretically can happen. The other one can't. So now you can figure out how much carbon disulfide will be left over and how much oxygen will be left over. Right? All right? See if you can put those numbers in. So what did you put in for the oxygen? 0. Yeah, there's none left. 0.0. The carbon disulfide, what is it? 30 minus 27.7 is, what is it? 2.3? All right. 30 minus 27.7 equals 2.3. All right. Okay? So it's kind of different. This is the last one. This is your typical limiting reagent type question, right? They're going to give you the reactants, and they want to know how many grams of HNO3 are you going to get. So there's a more typical question. You can do this. I think you should be able to ace the quiz on Friday. So if you're not so sure what I did on the last one, just ask. So did this one make sense? Okay.
It took a while, but I got it.
Yeah. Well, that's as hard as it's going to get.
How do we get these again?
Okay. So first, do you see why this one doesn't make sense?
Yes.
Because you don't have enough oxygen. All you have is 35.
Yes.
So this one can't happen. So if 35 grams of oxygen react, that means this stuff must also react too. Well, I have 30 though. So
Okay.
30 minus 27.7 would be the grams left over. And then if 35 grams of oxygen react, I have 35 at the beginning. Well, 35 minus 35 is 0.
Thank you.
For which one? Okay. Grams of NH3, 4 to 6 and 18. Okay.
It's right here.
Okay. And then you have to do the same thing again for this one.
So double.
It's double the work today.
Okay.
Right? So you're going to do it again, and you're going to get 22.
Okay.
So when you get 22, it's going to be the theoretical yield, the smallest answer. And that means the reactant that gave it, the oxygen, is your limiting reagent. That's a 2. This one's a 2, isn't it? 2 moles of HNO3. Yeah, good. And then do the same thing for the other guy. I don't know if it would help you, Annabelle, but see what he's doing? See how he's just putting in the units? Now he's going to put in the numbers?
That's worse.
That's worse? Okay. Yeah. Looks good. Daisy, are you getting this?
Okay, cool.
So how many grams of HNO3 will be produced? Okay, you're done. So either it's 16 or it's 1.91.
Is it always the smallest?
It's always the smallest. So that's your theoretical yield. That's your limiting reagent. Because 2.1 grams of NO2 can only make that amount.
Mhm.
That's the maximum. It can't make 16. So this one is a waste. This one's garbage.
Yeah.
So Daisy got 1.91 as her theoretical yield. Anybody else get 1.91? Yeah, you got it? Okay. 1.91 grams of HNO3. If you got that, you're good to go.
Oh, it's 1.9.
1.9 something. Yeah, that's it. Yeah, that was the last one. Yeah, you always take the smallest answer. Because the other one, if you take a look at it, you got 1.9 and 16. So all of this react, you get this amount, this amount. Well, that's not even close to 16. So this stops. This reaction stops when you get this amount of product.
Oh, okay.
Because he's all
There's a
gone.
lot more to
Yeah,
it.
this one's a waste of time. There's no way you can happen. It's impossible.
So just that is.
This is your answer. That's your theoretical yield
Theoretical.
and limiting reagent.
Okay.
Did you grab that?
Yep.